Hello, so let's talk about Srinivasa Ramanujan, an Indian mathematician whose achievement to the theory number is really considerable. So he's born in 1887 in Erode in India, and he comes from a poor family with traditional values, where his dad was a clerk in a sari shop. His passion for mathematics started at a really young age, and he learned the basis of many theory by himself. So he enters the Cambridge University in 1914 with the help of Godefroy Harold Hardy, who is an English mathematician. And together they work on mathematical analysis, number theory, infinite series, continued fractions. Unfortunately, he dies in India, back in India in 1920. So the first letter he sent to Godefroy Harold Hardy started his whole study at the University of Cambridge. And in this letter, he explains his situation in India and many of his discoveries from a mathematical point of view. And what's fascinating is that this big mathematician who is Hardy was really impressed by this letter, and this led him to bring Ramanujan at Cambridge University, where Hardy became his tutor. So among the several discoveries of Ramanujan, I will try to explain the analytic continuation of gamma function, the Mach theta function, and the partition problems. So as for the gamma function before Ramanujan only existed according to this blue curve. But Ramanujan demonstrated that no, there is also those curves that are the gamma function according to negative integers that exist. So, but how? So the gamma function is an integral for which when we have a negative value, according to this, it doesn't work because we have a fraction. So it cannot be expressed, it will be like growing towards infinity. But what Ramanujan demonstrated is this function here, where z will be z plus 1 divided by z. So the gamma formula here, the t here is gamma. And working backward, he could find the asymptote and at which the function exists, doesn't exist, sorry, -2, -4, -3. And this was really groundbreaking because a whole new world, I'd say, of the function existed now. So yes, many of the application of this function are present in integration problems, calculating products, and analytic number theory. About the Mach theta function, so this function is really special. One of the functions that Ramanujan worked on, and this function is present in the string theory and explains a phenomenon as BPS states and also the Umbral-Moonshine. And here are the equation of those functions. So the partition problems. So Ramanujan worked on the function that describes the number of ways to express the sum of a precise number according to positive integers. So this partition formula that he worked on is present in the string theory, and here is the partition function in the formula of string theory, one of the formula of string theory. So the Hardy-Ramanujan asymptotic partition formula is actually is expressed just here, just as you see here, and it took 5 years to find this equation that where n is the greatest, this equation is the more precise. So greater is the n, the greater is the approximation of the ways we can describe as the sum of a precise number according to positive integers. So this is used in the string theory. As you see, here are some equations that we use in string theory, where the partition function is here and also here. And yeah, so it's actually his unique approach towards math, because Ramanujan is known for using different type of notation and really like an approach that is really innovative and that was not really known at the time. And the fact that also he worked with one of the greatest mathematicians in the world without even having any university background, that's really impressive. And the fact that he just brought a substantial contribution to the understanding of the world, and that makes him just a pure genius. And special thank you to Malik Amir, a graduate researcher at Lausanne who helped me with this project. So thank you.